Welcome back, Honors 317, Essentials of Life, Air and Water. In this set of PowerPoint slides and videos, we're going to focus on some applied examples as well as providing some historical perspective on flooding and flood control in the United States. So with that said, I'm going to open up this image here that shows you a picture of Cincinnati. And this is 1997. That's the Roebling Bridge. It was the original model for the Brooklyn Bridge, constructed during the U.S. Civil War and finished the year after the Civil War. This is Riverfront Stadium. Back behind me on the picture there, that's old Riverfront Stadium and that same bridge. That stadium was replaced by Great American Ballpark, and they've since destroyed it. But that is the 1997 flood. There was another flood event, though, that happened much earlier than 1997, 60 years prior, in 1937, that changed the face of the Midwest and Southeastern landscape of the United States for decades through creations like dams and other water control projects because of how horrible the 1937 flood was. So I'm going to open up a video from KET to let you see what the impacts of the 1997 versus actually the 1937 flood had on Kentucky. So let's pull up that video. Okay, so as I start this video up, you're going to hear President Roosevelt, Franklin Delano Roosevelt, speaking about the New Deal, and then the rain starts.
Of the employment of labor at a reasonable wage. For the emergency purpose of the NRA was to put men to work. And since its creation, millions of hitherto underprivileged workers are today far better paid than ever before. The gain has been substantial, and everybody knows it.
But the sense of security which the New Deal brought to the city was not to last. In the January cold of 1937, it started raining. 2 weeks later, it had not stopped. 19 inches of rain had fallen on top of snow. The river was rising at a rate of 4 inches an hour. As the water still continued to rise, people were abandoning their homes, getting out with whatever they could carry. Some left the city altogether. Once again, Louisville was face to face with catastrophe. 40% of the city was underwater, 200,000 homes. President Roosevelt declared Louisville a national disaster area and sent troops to patrol the city. 500 WPA workers were brought in to fill sandbags. The water had come as far as the east end of Broadway, which was a mill race with a strong current down the middle. But the west end was worse. There, the river had risen over 50 feet. People found themselves stranded and helpless with little heat or food. But a vast rescue operation was organized by the mayor to deal with the problem. Cooperation and immediate action to help came naturally, but this would stretch the city to its limits. They worked day and night, rescuing 100 families an hour. With telephones mostly out, the principal line of communication is WHS radio, which relayed more than 10,000 calls per Food and shelter had to be found for thousands. The refugees were relocated in schools and churches in the high parts of the city not flooded. A pontoon bridge made of whiskey barrels was built over Baxter Avenue, a fragile link to keep the city moving. life of the city was geared only to survival. With no industry, no business, little transportation, and finally no source of electricity when the hydro plant went out and the city was plunged into darkness. All supplies had to be brought in by boat. And in some cases, the boats that brought in the supplies were used to carry out the dead. Miraculously, only 200 died. The water had crested at 57 feet on January 27th and was on the way down. But the danger was far from over. With the sewers backed up, there was the constant threat of epidemic. They set up impromptu health stations to vaccinate the whole city for typhoid. There were precautions for the worst that might come, including digging a mass grave in Cave Hill. Later came the threat of fire from the oil and gasoline on top of the water. The worst fears were realized when the Louisville Varnish Company plant caught on fire, sending out flames over the oily waters in all directions and threatening parts of the city. But the fire was contained. As the water receded, the extent of the damage became painfully clear. The muddy Ohio had penetrated into every corner and closet of nearly half the city, all the West End downtown, leaving behind a worthless mess. The river had receded, but much of the floodwater was left behind in the basements and cellars of the city. It was a slow and hard process for some. As citizens returned, they surveyed their ruined homes and belongings. Damage was estimated at $100 million. The city began the process of sifting through the mess, trying to recover what little was still salvageable. The tobacco warehouses were especially hard hit. The simplest solution for the tons and tons of rubbish was to dump it. From the very same bridge which had been dedicated to Louisville's dream of prosperity only years before. Now it was hardly a place from which to consider the future. Prosperity seemed more elusive than ever.
Guys probably are like, man, couldn't he show some more positive or uplifting videos? But the city of Louisville did bounce back, as well as much of the Midwest and those cities that were all affected up and down the Ohio River. To this very day, you can still listen. There's bluegrass songs called, the Flood of 1937, or Pikeville Flood of 1937. It was a very historical moment in the history of the United States. And, you saw those images of them. They built a mass grave in Cave Hill in Louisville. It's kind of remarkable. So I'm going to pull up some slides here for our applied examples. And as I pull it up, you should see, okay, so here we go. So this was just a recap of the city flooding versus rural areas. We'll skip that. But yeah, here's another image of Cincinnati in 1937 being flooded. So all up and down the Ohio River, from Pittsburgh all the way to St. Louis, all those small towns, Hopkinsville, Owensboro, Evansville, Indiana, you name the town, Madison, Indiana, just up and down the Ohio River, all those horrible factors that led to that flood impacted everyone. So what makes a flood happen? Obviously, how much it rains, the duration of the flood, of the storm, so how long does it go on? If you had a frequent or return, it happens over and over again. Maybe there was a lot of snow on the ground that melted, which was the case in that 1937 flood. What's the storage capacity? Do you have wetlands and bottomland forest along the side of the creeks and rivers to give the water a place to go? Are the creeks and rivers in tight valleys where the water has to flow out fast? Runoff factors. In 1937, a lot of our forests were denuded. They were gone. So there wasn't a lot to hold the water on the soil, and a lot of soil was barren. Farmland wasn't being properly maintained like it is today. So how much, is impervious or rough? That wasn't so much an issue in the 1937 flood because concrete wasn't as pervasive as it is today. But because of that, in 1937, those floods were so horrible. In 1938, the U.S. Congress acted and created the Flood Control Act of 1938. So here's a tower over at Carr Creek Lake in eastern Kentucky, where the dam is dammed up, part of the flood control projects that keep water from overflowing the Ohio River and the small streams ever again, even though we still have flooding, but not like we could have. Here's an image of Harsha Lake just east of Cincinnati, another big Corps of Engineers project that dams up the East Fork of the Little Miami River to keep the water from flowing into the larger rivers. All core lakes have a guide curve where they try to maintain the lake level, but sometimes the lake has to hold back water, so the lake level goes up. And sometimes they are trying to maintain their guide curve, but then you might have a drought. When they have a drought, they can cut back the amount of water that flows out. So when they need to hold back during heavy rain events, they can do that, and then when they're ready to release lots of water, they can do that. But sometimes when there's a drought, they hold the water back and manage its flow, and only 31 cubic feet per second were coming out of this particular lake during a drought period. But earlier in the year, they were releasing 3,000 cubic feet per second. So you can see how we can control the flooding by using the lakes and the dams that created those lakes by the U.S. Army Corps of Engineers. All right, so that's a little bit on actual flooding. I'm going to give you an example or project assignment on looking at flooding in the United States and in Ohio and in Kentucky. I'm going to give you the Cincinnati example, where I asked you how many floods happen over 100 years and how many 100-year flood events could potentially happen. So it's important to know that like a 100-year flood event does not mean that the event only happens once every 100 years. It means that the probability is that it happens once every 100 years. So if something is a rare event, it's better that it would be called a 1% chance flood rather than a 100-year flood. But people like simplicity, and sometimes when we simplify things, we also confuse people. So just because something's a 1 in 100-year flood, it's not like nature's just like sitting back waiting and saying, boy, I'll just wait, a couple more years till we hit year 100 and I can flood the place again. It's the probability in any given year is 1% if it's a 100-year flood. The probability in any given year is that there could be a 50-year flood would be 2%, because there should be 2 50-year floods in 100 years, but it doesn't mean that it has to be that way. It's a probability. A 50-year flood event is once every 50 years, or there's a 2% chance every year. A 10-year flood event, there's one flood per 10 years. There's a 10% chance in any given year that it could do that. So I'll give you guys an example to kind of go over that for the class. All right. So Moving on to the last slides we'll get into is characterizing watershed boundaries. So how do we make watershed boundaries, and how do we not just make watershed boundaries, but how do we also label streams and rivers? So there's a thing called the Strahler method for characterizing first order, second order, third order streams, etc. So you will get an example on how we do this, and I'll describe that here in next video.